modeling of display list. In continuation with the module 5, we have a topic called as programming event driven input. That is, what is programming event driven input? We have seen how an event is being created and how it is being looped so that an input can be provided to it. Similarly, OpenGL also supports some window events with respect to event driven inputs. What happens in this window events is the window is actually being resized, then the window should be drawn with respect to its contents. Then a keyboard on a particular uh, a key on a particular keyboard will be pressed or released. A mouse has to be moved or mouse button should be released or pressed. So these are some of the events happening with respect to the window events. Whatever the events I told, such as keyboard events, mouse events, as well as window events, these events are actually called as event processing, which are basically on callback functions. To take an example, we saw some programs, right, which consist of both keyboard functions as well as mouse functions. How did we use those functions? We usually define that particular functions in the program as a callback functions. I can tell those functions as callbacks, which are being represented in the program. So why is it necessary? Why these kind of event driven functionalities are necessary? That is, event driven inputs are necessary. It is necessary because we will be writing functions for some specific task, right? For specific events, we'll be writing those functions. If I take an example of a keyboard function, we'll be using it for some specific task or some specific event to be conducted there. If I take an example of mouse event, we'll be using mouse options there. So it is necessary to write these kind of functions to process some specific events and set them as a callback in the program, that is in specified window. Whenever we call a function, that is a keyboard function or a mouse function, we'll call that callback function right in the program. So that is what it specifies. Then when event occurs, that is whatever the event, such as this event driven input events occurs, it is basically a callback function which is being called. Do remember, if you are using any type of functions, that is a keyboard function or a mouse function, these functions should be called in the form of callback function. You can't create such events separately. You have to create a function and then you should call that function as a callback function. Then what kind of library is being used in such kind of function is, as we all know, glut library is used in this functions. Basically these functions comes under glut library. Glut basically handles events with callback functions, as we all know. Similarly, if you want to consider these functions to be implemented, so you should be familiar with the glut library. Then if you want to handle an event such as a mouse movement or a mouse event, you need to write a function, right, that basically performs the desired action. Before defining these callback functions, you have to define a function, as I said. Then I will link the callback function as well as the function which I have defined, right? So while this linking, you are creating a register which consisting of name, size, argument, or functions which actually consist of some values. So those are nothing but the program event given input. Then what did we study in this section? What did I explain just now? In this section, we develop event driven input through a number of simple examples that use the callback mechanism we introduced earlier. As I told, whatever the functionalities you will be using, such as mouse callback function, keyboard callback function, it basically uses the callback mechanism. Then we will examine various events that are recognized by the Windows system and write callback functions that govern how the application responds to those events. That is, as I told, you have to define a callback function. You have to write a function and then give that function name as a callback function in your main program. Basically, in program event driven input, it consists of some two important functions, as we are familiar with. That is nothing but keyboard callback function as well as mouse callback function. So we'll study in detail what is this keyboard callback function and mouse callback function is. Then, as I told, what is a mouse callback function? You are defining a function, you are writing a function outside the program, that is globally, and defining that function in the main program, that is internally, as a callback function. How to use this mouse function, that is, how to use this pointing device. So first, to be familiar with this pointing device, it is defined by two types of events which are basically associated with pointing device. One is a move event as well as a passive event. What happens in move event is this kind of event is basically generated when you are moving a mouse or whatever the hardware device, that is mouse is. If you are moving such device, this basically this pointing device comes into consideration. That is, this event occurs there. This is generated if the mouse is moved with one of the buttons depressed. That is, whenever you move a mouse by pressing any of the key, either of the key in the mouse, this move event occurs. When this passive event occurs, this is generated if the mouse is moved without a button being held down. That is, if I just move the cursor, this kind of event. To take an example, you can check out the cursor is moving onto the screen, right? So this kind of event is called as passive event. So how to use these kind of pointing devices is we'll distinguish these kind of pointing device with the help of two events. One is move event as well as a passive event. When does this move event happen? Move event happen whenever you press a button on the mouse and move the mouse, then this move event happens. Whenever you release the button and just move the cursor, this passive event happens here. Then, a mouse event occurs when one of the mouse buttons is either pressed or released. So, this is the point you need to remember. When does a mouse event happen? The mouse event happens whenever you are pressing a key, or you are just releasing a key, or you are just moving the mouse around to the screen. So, this is how pointing device comes into consideration, how we use pointing device. Then, how mouse callback function is being implemented in the GLUT library. We specify the mouse callback function in main with the GLUT mouse function, mouse callback function. So this function we have already seen, which basically tells you are using a mouse event here, which tells you are defining this particular function inside the main function. Check out the point. You will be calling this callback function inside the main with respect to GLUT library, that is using GLUT call. So this is the function which basically calls a callback function called mouse callback function. The mouse callback function must have the form void mouse callback function. Then the parameters which are being defined as integer. One is button, that is nothing but whatever the button is being present into the mouse, in which state the mouse is. The mouse is moving, or the first button is pressed, or the right button is pressed. Then two variables x and y. So this is the definition of a mouse callback function which you need to define outside the program. That is the main program. Then the code for this would look like, that is an example of this code if you are using mouse callback function. So this is the function you have defined, which consists of some functionalities. Suppose if button is left button, that is if you are pressing left button and you're scrolling it down, then you have to exit. If this particular statement executes with respect to the callback function, if this condition is met, you are just coming out of that particular program. This is just an example. You are just coming out of the loop if this particular condition is met. Then we have some additional points with respect to mouse callback functions. With this code, if any other mouse event had occurred, no response action would occur because no callbacks corresponding to the events has been defined. That is, whatever the code we saw in this slide, you can see there is no callback function which is being defined, right? You are just coming out of the loop. This is the loop created here with respect to mouse callback function. You are just coming out of this loop so that the program, the function ends here. So that is what the note given here. Some examples of the mouse callback function: to draw a box at the mouse location when the left button is pushed, and terminate when the middle button is pushed. So these are examples. If you want to this is an example where you are just drawing a box at the mouse location when left button is pushed. So you need to terminate when the middle button is pushed. the middle button. So how to do that? You are creating a window here called square. Then you'll go to initialization function. That is, you're initializing a glut library here using these arguments. Then I'll give reshape function with the help of which you can reshape the primitive, the type of primitive you want to display. And then I'm calling a mouse callback function, and then I'm displaying that particular function onto the output screen. So this is an example of a mouse callback function. Then similar to that of mouse callback function. In the mouse callback function, as you saw, there are two different events happening there, right? One was reshape event and the display event. Check out in the program, there was one reshape function and the displays function. So what is this? In display function, why do we use this display function? Reshape function is basically reshape function is generated whenever the window is resized. That is, if you are changing the size of the window, this function should be used. This is typically from user interaction. Then as this reshape event is basically discussed in this module in further stages, we'll see it in detail. Just to remember why reshape event occurs, this reshape event is occurred whenever you are just resizing the window of your screen. Then how, when is this size changed? This is basically dependent on the user. Whenever the user wants to change the size of the window, he can just use this reshape event, that is the reshape function, and then he can resize the size of the window. Then we have something called as display event. Why is this display event used? Basically used to display the output onto the screen. Function since things are only drawn when the mouse button is pushed. In the previous example, we need not define a display function separately, as we are defining a mouse function. When is that mouse function coming into consideration? Whenever you are pushing some buttons or there is some actions happening with respect to the mouse. So at that case, the display function comes into consideration. But if you are using this display function, we need the library called as glut. How to use this glut library? How to use display function in the glut library is you are just defining a function called void display, as we have represented in all our programs, lab programs. We have defined a separate display function which consists of some functionalities inside it. So this is the explanation of reshape as well as display function. Then this is another example of mouse callback function where you are defining what kind of button. If the left button is pressed and you are scrolling down, you have to draw a square with respect to parameters x and y. If the button, if you're pressing the middle button and you're just scrolling down, you have to come out of the loop, that is come out of the mouse function. This is another example of mouse function. In your internals or in your externals, if it is being asked to define or to explain mouse callback functions, you have to explain the mouse callback functions and you have to explain one or two examples of it. Then these are some examples related to mouse callback functions. Then this is so check out here in this function, whatever we are using in this example, we have defined a draw square function with two parameters, where we have defined one variable called y, which consists of these values. So with the help of this function, you are just drawing a cube, I can say. You are drawing a square of type polygon, and then you are defining vertices of it. The position written by the mouse is in the Windows system at the topmost left layer. Hence, we have to flip it. That is, this is just flipping of a square example where you are just rotating a square by pressing callback functions, that is your mouse functions. Then the next topic is window events. As I defined some window events with respect to programming event driven input. As I defined programming event driven input as some window events. So we'll check out what are these window events here. So when this window events comes into consideration, when you are defining a window, you are renaming a window and you are changing the size of the window. Basically, most of the window systems, it basically allows a user to resize the window interactively. That is, as we know, we can change the size of the window in our program. We can change the position of the window in our program. Uh, when is this used? When is this considered? This is done usually by using a mouse to drag a corner of a window or a new location. That is, you are using a mouse with the help of which you are reshaping that particular window size. Then, whenever a user moves or resizes the graphics window, the software, that is OpenGL, it basically informs the program that you have registered to some callback functions. When is this happening? Whenever there is a problem with reshaping, that the user is likely to change the shape of the window. So what is the function we'll be using for changing the window size? As I told, let reshape function, in the braces, in the parenthesis, we use reshape. If the window size changes, we have to consider three questions there. You need to remember these points. Do we redraw all the objects that were in the window before it was resized? The first point you need to remember is, if you are displaying this as a window, okay, take an example. If this is an window here, you have drawn some objects. Suppose these are the objects I have drawn here. So you need to remember, you need to question yourself that if you are changing the size of the window, is the size of the objects which you have drawn here is will also change? That is one key point you need to remember. What do we do if the ratio of the new window is different from that of the old window? So what is the solution if you are just changing the window size? What is the solution after changing the window size? What is the ratio that you got? Change the size or attributes of the new primitives if the size of the new window is different from the old window. If you check, if the ratio of the new window is different from the old window, that is, the size is different, you need to check the primitives is similar, or the primitives have changed with respect to that window which you are displaying. So these are some of the questions you need to ask yourself when you are changing the size of the window. Then I have taken an example where we ensure that squares of same size are drawn regardless of size or shape of the window. Therefore, the screen is being cleared each time if it is resized, and we'll use the entire new window as our drawing area. That is, whenever we are drawing a square onto the screen, that is with respect to the example, we'll be clearing the screen each time so that it is being resized and a entire new window is being displayed onto the screen. As I told, this display functionalities uses the reshape functions. The reshape event returns the height and width of the new window. Why do we use this reshape function? What is the output of this reshape function is, it basically gives you the height as well as width of the new window. Why do we use this function in the OpenGL? We use these functions to create a new OpenGL clipping window using the orthographic functionality called as GLU Ortho 2D, with the help of which you are just displaying the two-dimensional orthographic projections. Then, as well as a new viewport with the same aspect ratio we get, we can be using this kind of functions. Then we'll clear the window to black, that is any color, that is background color. So this is the function where you are displaying a cube, you are drawing a cube each time, you're drawing a square each time, and then you are making you are just changing the size of the window, and then buffering it, then resizing it, then changing the color of the background to black. So with the help of this void my reshape function, you are defining two variables w as well as h, which of type gl size I, that is nothing but integer type. Then you are defining the type of projection, you are loading the identity matrix, the initial matrix as identity matrix. Then you are drawing an orthographic two-dimensional object with respect to these parameters. Then you are defining what kind of viewport with respect to width as well as height, and then you're clearing the background finally, and then putting that particular parameters into the buffer, and then you are looping that particular function. Then that is how you can perform some of the mouse callback functions. As we started with mouse callback functions, we ended up with what? Window events. So as I told, the event driven functions basically consist of two types. One is mouse callback function and the other one is keyboard callback functions. Window events, we saw what happens in window events. Basically resizing of the window happens there with respect to position as well as size. In keyboard events, what are keyboard events? What happens in keyboard events? As compared to mouse, you need to click either of the mouse buttons or the center button. But in keyboard events, it consists of many keys, right? It depends on which key you press. It is also user dependent. It is also depend on the user interaction. Basically, keyboard events are generated when the mouse is in the window and one of the keys is depressed. That is, if there is no mouse located onto the screen, if you press any key from the keyboard, you won't know where the excuse me, where the key is getting pressed. So if I don't locate a mouse, suppose I want to type as after such, but you need to locate the mouse here, right? You need to locate the cursor here so that you can type as here. Without locating the mouse function here, you can't type as it is. So mouse function is also important related to keyboard functions. That is the key point you need to remember. Whenever a mouse point is being located onto the screen, you have to do the keyboard functions there. That is, you should use keyboard mouse function as well as to use keyboard function. That is what the first point says. Glut ignores key releases. So this is one of the advantage of glut library, where it basically ignores if the key is pressed and suddenly released. So that kind of functionality it basically ignores that. All the keyboard callbacks are registered in a single callback function called let keyboard function keyboard. Basically, if you want to use keyboard events and if you want to call keyboard callback functions, you have to use this particular function called let keyboard function by giving the parameter as keyboard. So this is an example of a keyboard function where it is just checking for the condition. If you're pressing the key as small letter q, and if you are pressing as capital letter q, you are just coming out of that particular keyboard function. That is a simple example of keyboard event. So that was about keyboard functionalities. Then we have the display as well as ideal callbacks. That is the display functions. What happens in display function is basically a display function is invoked when the library glut determines that the window should be redisplayed. That is, you are just invoking this display function whenever a window should be reshaped. Then what happens in display function is basically a window is being initially open there. Basically, whenever you call this glut display function, a window will be created or open. We can also tell glut to call it with glut post redisplay. That is, you are again calling the display function to display the display screen onto your output screen. That is about how to use display functions. What if the callback functions are ideal? So we'll be using a function that is callback function called ideal. The ideal callback is invoked when there are no other events. That is, if in the program I have defined two events, one is keyboard events and the other is mouse event, I will execute and complete these two callback events. But at the stage when there are no events happening, when there are no callback functions happening, at that time this ideal callback function is being revoked. That is initialized. The ideal key callback function is initialized at that time as an default. Its default is the null function. That is, this function doesn't consist of any functionalities. That is nothing but it is just in the stage of null. So there is something called as window management. What happens in window management is basically you are just create in window management. What is the meaning of management? You are managing the window. That is, you are managing the size of the window, name of the window, position of the window. These are the three functionalities comes under window management. Glut also supports both multiple windows as well as sub windows. That is, you can use multiple windows onto the screen, and you can also use sub windows. That is, you can create window under a window. So that is one of the functionality of glut library. We can open a second top level window by creating an id by assuming this function to it. That is glut create window second window. That is, you are creating a second window inside a window by assigning some value to it. Then whatever you have used here, that is the id, this id allows you to select which window to work with. That is, as I had explained this, you are just using some unique identification number. First, if you want to create three display windows, you should set an id for the first window. Second window also you should give a unique id. For the third window as well, you should give a unique id there. With the help of this id, you can set which window to be displayed onto your screen. If you have already displayed one screen, that is one display onto the output device, now you have to display another window under this particular original window. By specifying the id of that particular display, you can display a number of windows onto your screen. We can make this window have different properties by invoking the glut init display mode before glut create mode. That is, whatever this function you need to use, this should be given before glut create window, which basically tells before creating the window, you have to initialize that particular display mode with respect to that particular library, that is glut library. And each window can have its own set of callback functions, because callback specification refers to the present window. As you are defining, suppose as I told an example of displaying three windows onto the screen, each window consists of its own callback functions. It is not up to the user, it's up to the callback function you are using into the displays. It basically depends on the number of displays you want to display onto the screens. There are a huge number of callback functions can be included inside one display function as well. Then that was about callback functions, that is keyboard callback function as well as mouse callback functions. Then we have something called as menus. What is the meaning of menu? That is nothing but listing of options. Suppose to take an example of an hotel. If you're going to hotel to have something, what is the first thing you do? You basically check what is the menu. What is, if you're having lunch in a hotel, you'll check what is the menu for your lunch. So similarly, in OpenGL, you can specify menus to that particular output. Suppose if this is the output screen which is being displayed onto your system, if you just right click, you should get some list of menus. If you give one option to that particular menu, the program should be executed. The program should execute that particular function and return you the output of that particular menu. So this is how menus work. Basically, glut provides pop-up menus that we can use with the mouse to create interactive applications. Suppose your next lab program will be displaying of curves onto your screen, that is display of flag. For that particular output, if you are pressing right click, if you give right click of your mouse, it will ask some options. Suppose for changing a color will be the one option, coming out of the program is another option. If you press exit, the program should come out of the output loop and it should come to the normal screen. So these are some of the menus which can be used in graphics. Using the menus involves taking a few simple steps. First, you have to define the entries, link the menu to a mouse button, then define a callback for each menu entry. That is, first you should specify what kind of entry it is. That is, whenever you click a right click onto the screen, you should there should be listed some entries there. Then those entries should be linked to the menu whenever there is a mouse button. That is, whenever you click onto that particular entry, it should directly go to the callback function and check what the function is doing. Then As I told, define a callback for each menu entry. That is, you are defining a callback. Whenever that entry is being pressed, whenever that entry is done, it should directly move to the callback function and check what the function is doing. So this is how menu works. So this is an example of a menu driven program. That is, you are defining a menu here. First, in the main program, you are creating a menu of name demo menu. Then you are adding the first entry of menu as quit, the second entry as increased square size, and the third entry as decreased square size. That is, the first option of the menu is quit. The second option is increasing the size. The third option is decrease the size. Glut attach menu. What happens? Check out the parameter given right button. Whenever the right button of the mouse is being clicked onto the output screen, these three options should be listed there. Whenever you call, as I have given IDs to it as 1, 2, and 3, whenever the option is pressed as quit, what happens if ID is equals to 1? Exit. It will exit from the output screen. If ID is equals to 2, what happens? The size should be increased. Here, the size is increased by 2 times. And then if ID is equals to 3, that is decrease the size, where the size is greater than 1, you should decrease the size by dividing it by 2. So this is how the callback function works with respect to mouse events. Then you will be displaying that particular output till the condition is being satisfied. So this is how a menu driven program works, menu function works. Then our library, that is glut library, basically supports hierarchical menus. What is this hierarchical menus? First, check out the block diagram. There are two blocks here. One is quit and resize, and the other one is increase square as well as decrease square. Suppose look out the program given here. What is the meaning of submenu is you are just creating a menu here with respect to the menu by giving entry of each event by passing IDs to it. As I told, if the first option is quit, you are if the first option is pressed, you are just coming out of the loop. If second, the size of the square is increased or it is being decreased. So this is how the hierarchy of the menu which we have created in the example works. With related to menus, we also have something called as picking. What is this picking? This is also related to your pointing device. What happens in picking is, suppose, what is the basic meaning of picking? You are just pointing to something and you are just taking it up. So this is a similar definition of picking. In computer graphics or in computer applications, it is basically useful for the user to point to something and then have the program figure out what is being pointed to. So this is basically called as picking in computer graphics. That is, picking is an input operation that allows the user to identify an object on the display. That is, you are basically we'll be using picking in every program. What does this tells? Basically, you will just send a input for that particular program. Now you are waiting for the program to select the output, right? So this is actually called as the concept of picking. Although the action uses the pointing device, the information the user wants is not a position. That is, you are not taking the position. Basically, you are taking the content of the particular position with the help of picking function. Then a pick device is considerably more difficult to implement a modern system than is a locator. This basically tells if you are using any picking devices, it is actually difficult to implement a system which is comparatively easy to that particular locator. What happens at that time? The text gives some ideas. That is, if you are using text in this particular model to implement the picking device, the text which you have defined gives some ideas to it. Then we have something called as a simple paint program. So that was about picking. No much about picking was given with respect to your syllabus. To give you some basic steps of picking, first you have to select the mode. That is, selection mode should be done. Then you have to select the buffer. Then you have to perform push and pop operations onto the picking part. Then, as I told, we have a simple paint program, which basically tells you how you will be implementing paint with respect to your computer graphics. So whatever the code you are implementing for simple painting options, it basically consists of some options. The first option should be ability to work with the geometric objects. What is this particular thing happening here? What happens in geometric objects? The program should be able to identify what kind of geometric objects it should be. Then it should manipulate some pixels, that is the ability to manipulate pixels, that is it should be able to calculate the number of pixels which are being defined in the output representation. Then provide control of attributes, that is it should provide the user can change the color size of that particular program. That is one feature. Then include menus and then behave correctly when the window is moved or resized. That is, once you give menus to it, after changing the size of the window should be displayed properly. So these are some of the key features you need to remember while you are programming a paint program. So this is the option given here. This is basically a representation of a paint program where you have defined three different objects here. One is a square, one is a triangle, and another one is a dot here. These are geometric objects. Okay. So the first option is a line. I can call this as also a geometric object. A single line is drawn, then the text is drawn. That is A, B, and C. So how this paint program works with respect to mouse callback functions. If the right button of the mouse is being pressed, you are embedding two options here. One is quit as well as clear. If the middle button of the mouse is being pressed, these are the three functionalities it is been happening. This is the exception case. This is the code part which you are representing here. For colors, these are the number of colors you have to define. For pixel size, what are the operations you should do? One is increasing the pixel size and the other one is decreasing the pixel size. Then the fill area, what you have to fill there, if the object should be filled or not with respect to fill function. So that is how a paint program can be implemented with respect to your